So, another blog comment via video from Bitcoin Buildify. The topic of this one is, what is blockchain technology? So this is blockchain technology is in some ways kind of the heart and soul of cryptocurrencies. Not entirely, but it plays a huge part, and there really wouldn't be Bitcoin without the blockchain. So in this post, I'm going to try to give a very simplified kind of general breakdown of what the blockchain is, kind of a little bit about the history, some basic features, and then maybe a little bit about some of the implications. But generally just a real basic kind of working understanding of what the blockchain is. So first, the blockchain technology, this type of platform, actually has a lot of implications, and like any other platform, it can be used for a lot of different things. I mean, you can make a lot of different variations. So to keep things simple, I'm just going to talk about the Bitcoin blockchain, which is kind of the original template for what has followed in the world of cryptocurrencies. So please keep that in mind. Bitcoin blockchain is not the only version of blockchain there is, and blockchain is not only applicable to finance. So that's kind of part of what makes it so amazing and potentially revolutionary. Okay, so let's get started. First, a quick recommendation. If you really want a solid understanding of some of the finer details of blockchain technology, I would recommend the Bitcoin white paper. You can find it here on bitcoinbuildify.com. Just come to this article and click through, or you can do a Google search for it. It should be available publicly. Don't go paying for it or joining. You don't have to join any memberships. That's completely against the whole philosophy of Bitcoin. It's a little bit technical. It would help if you have some understanding of math and cryptography, but it's not, completely inaccessible. It's a bit of a read, though. It's not light reading by any means, but it's very much recommended if you want to have an understanding of what's happening. Okay, so with that said, let's talk a little bit about some history. The blockchain was first successfully implemented through Bitcoin, but if we go back to 1991, we can find a paper called How to Timestamp a Digital Document by Stuart Haber and W. Scott Stornetta, these gentlemen here. You could refer to them as the blockchain bros. It wouldn't be too far out of line. And in this paper, they were kind of proposing some ideas that it was really only the blockchain was able to solve. You can see the paper here if you come to Bitcoin Buildify. There are a few websites out there that want you to pay money to download it. Don't do that. It shouldn't be that way. But so what they proposed in the paper. Let me just jump to the abstract here. So the authors say, the prospect of a world in which all text, audio, picture, and video documents are in digital form on easily modifiable media raises the issue of how to certify when a document was created or last changed. Right, so we live in a world where you can basically copy and paste anything, and there's no way of knowing where it came from when it was made, if it's the original, if it's been edited or not. So they go on to say the problem is to timestamp the data, not the medium. Very subtle distinction. Continuing, we propose computationally practical procedures for digitally timestamping documents so that it is infeasible for a user either to backdate or to forward date his document, even with the collusion of a timestamping service. Our procedures maintain complete privacy of the documents themselves and require no record keeping by the timestamping service. So reading this, if you have an understanding of what the blockchain does, this sounds like a very kind of early version of it, although they don't explicitly offer any solutions. So the paper focuses on kind of three main areas. One is we're going to talk about digital item A as an example. Okay, it could be a Bitcoin transaction. It could be selling a house, a contract for selling a house or something like that. Whatever the document is, we're going to call it digital item A. So the first issue they address is, how can we prove that unique digital item A is really unique digital item A, right? In a world where we can just copy and paste things. Second, how can we reliably identify or make identifiable unique digital item A without having to share its specific contents with others? That's a really tricky question. And three, how can we do this without a centralized service, or without using a centralized service, and thereby having to trust a third party? So let's break these down. Number one is just saying, how can we prove it is what it is and it hasn't been altered since having been proved it is what it is. This is really easy to do with analog items, right? So, for example, a book, if you go to the store and you buy a book, it's very easy to prove that it is that book, right? It has the ISBN number, it'll have the date of publication, the publishing company, and all of the content will be there. It would be very, very obvious if someone were to have changed the book. I mean, you could do it, but if we're talking about like adding pages or adding chapters or taking stuff out, that's going to show up pretty readily, right? You're going to know what happened to chapter 7, or why is this, it's my point is it's pretty easy to do with an analog item to a certain degree. With digital items, not so much. You have to have some protocols in place, which the blockchain does. Number two, being able to identify the item as it is, but without compromising the contents of the document. So a good example in the analog world would be something like a paycheck being mailed to somebody's house, right? Or a power bill. So the package, the envelope it's in, to the company that sent it and to the receiver would be very readily identifiable as being what they are, right? So let's take a power bill. The power bill will have the name of the company, it will have the name of the addressee and their address. It will have all kinds of marks on it. Sometimes even the paper might be a certain kind with certain types of writing. So pretty much anybody who picked it up would be able to say, oh, this is a power bill for this person. But the contents beyond the name, how much the person owes, their account number, how much power they used, when the billing period is, all of that you would actually have to open the envelope to see. So they're trying to come up with a way to do this with digital documents, right? So yes, you want it to be identifiable, but you don't necessarily want all of the content exposed in order to identify it, right? That in a way that could not necessarily defeat the point, but it could dissuade people from using it. If there's zero privacy, you might just keep it to yourself or not use the service. So there's a whole kind of plethora of issues that come up with that. The third issue, not using a third party, well, this is basically because third parties tend to screw things up. They add fees, there's an element of corruption, there's an element of control and a lack of control for you that a lot of people want to avoid. And historically, whenever a system, especially for example like the economy, has collapsed, it's usually been the fault of a third party taking things too far. There's also a lot of issues with trust. I mean, it's actually very, very difficult to fully trust a third party with anything. So that's why they proposed the way to cover these three elements, right? One, guarantee beyond a shadow of a doubt that it is what it is, even if it's a digital document. Two, to make it identifiable without sacrificing privacy of the contents. And then three, doing away with the need for a third party, which is what people say when it's a trustless network, or I should say a distributed trustless network. It means there's no central control. So that is what was proposed in this paper, How to Timestamp a Digital Document. And the quest to solve these problems contributed a lot to the creation of the blockchain, Bitcoin blockchain technology. This paper is actually referenced in the original Bitcoin white paper. So another point worth mentioning, nowhere in this paper do the authors talk about money or digital money. If you read the quote, actually, the first sentence says, "The prospect of a world in which all text, audio, picture, and video documents are in digital form." They're actually talking more about intellectual property and digital documents as such, not really in connection to any specific type of document or content. So it's worth mentioning again that blockchain technology is not limited purely to finance. It's basically limited only to your imagination in terms of what you would want to do with it, with any kind of digital media. So it's pretty exciting stuff, and this is a big reason why people say that the blockchain technology is comparable to the next generation of the internet. I think I mentioned something like that up here. I'm trying to keep this one relatively short. I don't want to jabber too much, but this is worth mentioning. So today we're roughly at the same stage with cryptocurrencies as we were with computers in the early 90s. You'll find a lot of people feel that way. Where it goes from here is almost impossible to say, but most, myself included, believe that we will likely see a revolution in finance and the secured exchange of information, which applies to a lot of things, via cryptocurrencies, in the same way we saw a revolution in access to information via the internet. So the internet is an amazing, amazing platform, but in terms of secured transactions and, how could I say, kind of guaranteeing the legitimacy of things, it's kind of hard to do that on the internet, to say the least. The internet is very much about openness and ease of access, which is an amazing thing, but when it comes to making something accessible, but only to a certain degree, in a very secure, verified way, the internet has a few shortcomings that the blockchain technology template solves very, very, very well and very simply. So we're going to kind of touch on that. So what is the blockchain? It's essentially a database. That's the easiest way you can think of it. And what I mean by database is an organized and searchable storage of a large amount of information. But beyond this definition, the comparison, the similarities between how the blockchain works and, for example, a university database or a bank database work, they kind of disappear. We'll talk about that in a second. So what the blockchain does is it has an extraordinary level of both security and accessibility. And it combines the private and the public, the secure and the accessible. It sounds strange, like how can you do that and have it work? But basically anyone with access to the blockchain, in the case of Bitcoin, has access to all of the blockchain. And but this is an important point. Even though anyone can see any and all of the data stored on the blockchain, it's for the most part it's encrypted. You need to know the encryption of each transaction to find it. You might be able to backtrack if you knew when it was. And then, secondly, only the end users with the correct access keys to the transaction have any way of actually affecting it. So one user will initiate the transaction, so sending the Bitcoin. The second user with the correct access key will be able to both receive that transaction and then create another transaction from that address. The middle part, what the miners do in verifying the transaction, that's visible to everyone. Everyone can see that the transaction did happen, it's been verified, they can see when it happened, they can see how much Bitcoin was sent. But beyond that, they can't have any effects on the transaction itself. It's encoded, it's built into the blockchain. We're going to talk about that a little bit more. So let's move on to hashing, which you'll hear a lot in regard to cryptocurrencies and blockchain technology. So hash is an abbreviation of the term hash function, which comes from cryptography. It means to map data of arbitrary size to data of fixed size. So to put that less technically, it means to basically compress data. And by data, it can be a little bit or a lot. It can be somebody's name, or it could be the Library of Congress. The hash function will take that data and hash it into a code of a fixed length. It might only be 64 characters, 100 characters. All of that will be encoded. All of that data will be encoded into that code. So I've created a very simple visual, right? We have original data, run it through the hash function, hash, 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 and out comes this code. This isn't a random code that is just used to represent it. Like, oh, we'll just call it this. What's actually happening is the computer takes the data itself, and runs it through an algorithm which generates this outcome. So there is a connection, but to undo it is super, super difficult. Having the access key in the case of Bitcoin makes it quite easy. But that's kind of a separate subject. So hashing, you'll hear this a lot. Hash away, hash away. So all transactions on the Bitcoin blockchain actually become part of the blockchain. They're time-stamped, which gives them a specific origin in time. And then as the hash function is deciphered by the miners, the transaction is verified and added to the blockchain. And so it's this kind of interesting process where all of the transactions are stored in the block and kind of in a sequential way. And then all of the blocks are linked together in a sequential way. So the movements of the blockchain become the blockchain as it builds itself into the future. So in order to duplicate or falsify any one transaction on the blockchain, you would actually have to falsify all the previous transactions on the blockchain. So this is what makes it so secure, is that there's a kind of an interdependent, interlinking nature to all of the transactions. And each transaction is encrypted using a hash function. So even if you had all of the computing power to say, for example, let's first talk about the numbers. Okay, so I get kind of ahead of myself. At the time I wrote this, there were about 515,200 blocks on the Bitcoin blockchain. Each had a rough average of about 2,000 transactions. So this is equal to over 1 billion separate encoded transactions. That's a very big number. So if you did have the computing power to duplicate one transaction per second, right, which is currently basically impossible, it would still take almost 33 years to catch up to a point where a false transaction could be safely inserted or a legit transaction safely altered. So there is a direct connection between the transactions and the codes that represent them and the structure of the blockchain, right? So it's not like it's a database where information is just being kind of arbitrarily entered into a central database and then kept there in a mostly unsecure way. The transactions themselves and the information in the transactions are the database. It's kind of a different approach, but it's basically taking all the weaknesses of digital media and having them done away by this blockchain format, which encodes everything as it's happening into the nature, into the structure of the database. It's very simple actually, but pretty profound in terms of the implications it could have for security and privacy, and then kind of paradoxically also accessibility. So anyways, let's go on. What are the blocks, right, in the blockchain? What are we talking about when people say blocks? So a good analogy is if you were to imagine the blockchain as a book or a ledger of transactions. Each block could be imagined to be a page in the ledger, right? So this analogy is actually quite accurate. The information contained in the blocks is going to share a lot of similarity to the structure and content of ledgers you might find in real estate, accounting, or even the stock market. However, what is unique about the ledger, quote unquote, that is the blockchain, is its highly private yet highly accessible nature. So literally anyone in the world with an internet connection can log on to a blockchain browser, as they're called, and this is a website displaying the blockchain and its activity in real time, and see what's going on. So if you different blockchain browsers will allow different search criteria, but if you have an address or a transaction number, sometimes you can actually use the ISP, which is a little bit debatable in terms of... Anyways, you just enter that in and you can actually see the transaction on the blockchain. It'll zero in on the block, when it happened, how much Bitcoin, and anyone in the world can see that, which you might think is like, whoa, that's kind of dangerous, right? But you have to also remember that, or actually if you haven't even said anything about it yet. So although you can see information regarding addresses and amounts of Bitcoin sent, you can't see who is on either end or where they are. It's all just kind of blockchain lingo. It's all in the blockchain, but it's not tied to any geographical points. It's mostly anonymous. If you had access to the owner of the wallet's information, or you were somehow able to zero in on their ISP address, you might have some idea of who they are, but for the average person, you're not going to. It's going to be kind of hard to find out whoever it is. Which is why it's known as a peer-to-peer network. It's not a centralized network. Okay, so this ledger is not stored in any one place. It's distributed across all computers running on the Bitcoin network, which is what people are talking about when they say decentralized. We'll talk about the significance of that in a moment. This is another simple visual of what you could imagine the blockchain to appear as. It would have these blocks, pages in the ledger. It would have a header, a hash of previous block header, which is a connection to the block before it, the Merkle roots, and then a number of transactions and information about them. And they would each be connected to the next block and the block before it. Unless it were the Genesis block, which is the first block in the Bitcoin blockchain. That would not have anything preceding it. It would be the start of the sequence, and all of the other blockchains on the Bitcoin blockchain would be connected sequentially to the Genesis block. So each block has 5 main elements. The first is a magic number, which is basically just a code computers and software can use to identify the the block as a Bitcoin blockchain. A lot of other files and applications also have magic numbers, so I don't know why they call them that. Second would be the block size. So just like an MS Word document or an MP3 file, if you check the properties, it will tell you its size. Blockchain blocks will also do that. Next would be the block header, which has a number of different criteria, but first is a reference to the block immediately before it, right? So if it's block B, it's going to say, hey, I came from block A. 2 will be a compressed reference to its place in the blockchain. So if it's block 654, there'll be a little code called the Merkle root, which will allow you to determine that without investigating all the blocks before it. It's kind of a shortcut to see where it is in the blockchain. Third will be the time it was created. This is actually really important. Chronology, right? The flow of time. It's impossible to fake. So that's another important element in a block's header, letting everybody know when it was created and also when it was verified. Fourth is the transaction counter, which is just saying how many transactions it has. And then fifth are the transactions themselves. This is kind of the body of the block. And when we talk about looking at the blockchain, this is mostly what we're talking about. The transactions themselves kind of frozen in the block on the blockchain. So if you want to actually see the blockchain, you can go to blockchain.info and you can take a look there. They'll show you the most recent blocks, and if you have any information regarding any Bitcoin transactions, you can type that into search and it'll actually show you where it is on the blockchain, which is kind of cool. So anyways, what's special about it? What's the big deal about the blockchain? Well, it has a lot to do with record keeping, and that can be financial or otherwise. Blockchain technology introduces what can essentially be called triple entry bookkeeping. And this is a vast improvement over the older method of double entry bookkeeping. So double entry bookkeeping came around in about the year 1494, which is well over 500 years ago. And just about everything we do and how we do it, almost everything has changed a lot since then. But double entry bookkeeping hasn't. It's kind of surprising. So double entry bookkeeping focuses basically on two columns. You've got your in column and your out column, and the balance is changing according to that, right? So you can have deposits on one side and then withdrawals or expenditures on the other. Triple entry bookkeeping introduces a third element, which is communal access and verification. So it's distributed across the entire network, and everyone can see it, and everyone has to verify. Well, everyone involved with the mining process has to verify it before the transaction can be initiated and verified. This isn't true with double entry bookkeeping. It's centralized, so whoever has control over the books can change entries, which is pretty sketchy, and it happens a lot. With triple entry bookkeeping or blockchain technology, that can't happen. Well, it depends on the blockchain, but with the Bitcoin blockchain, it can't happen. So what this means, this has a lot of implications for record keeping and securing data in time as it was entered. But I'm going to talk about that in another post, uses and implications for blockchain technology, which is currently in the works as of early April 2018. Okay, so to continue, decentralization. This is another thing you'll hear discussed pretty frequently in regard to the blockchain and cryptocurrencies. If you want to get a better understanding of why it's such a big deal, I'd recommend this post, Cryptocurrency versus Fiat Currency. What's the big difference? Decentralization is one of the most powerful features of cryptocurrencies like Bitcoin, while centralization is one of the weakest features of our current mainstream economic system based on fiat currency. And again, it's worth mentioning this technology is not limited to finance. It can be applied basically to any industry that has a need for record keeping or tracking of information, which is basically any industry. But that's for another post. So suffice to say, the big problem with a centralized system is basically it's the equivalent of putting all your eggs in one basket. While you have one central point of control, you also have one central point of failure. So we can take this diagram here, right? The centralized system. This blue circle represents a centralized hub of access. So if you have access to this central hub, you can control the entire system. This isn't always a bad thing, right? So if we think of this as a tree, and this blue circle is the trunk, all of the nutrients flow to and from the branches back into or out of this central trunk. It's actually pretty efficient in this regard. Problem is, if you cut this branch, the entire branch dies. If you damage or destroy this central hub, the entire system dies. So it's efficient for some things, it's really inefficient for others. And everything has its place. With a decentralized system, there is no central hub, and each satellite or node is in touch with each other node, and they share in distributing and verifying the integrity of everything in the system. This one is not like a tree. It's more almost like a fungal network or something, where it's kind of responding and in tune with itself. But that analogy only really goes so far. So this is the basic idea, though. So for the centralized system, you control this, you control the entire system, for better or worse. For a decentralized system, you actually need to control the entire system at once, which is really difficult to do. So there's a higher level of security just inherent in the system. And strength. It's much more damage resistant. So that's kind of the long and the short of it. There's a lot more to it, but you can, find that out in further posts here or via your own research, via good old Google. Just some final words, kind of a little reflection on the benefits of decentralization combined with blockchain technology. Should be helpful in understanding not only the current craze toward this type of technology, but also its implications in terms of what it can do for the flow of data around the globe. So there is a huge amount of potential for what this technology can do, and we're really only at the beginning of its implementation. So it's a good time to kind of get involved with it, whether just kind of casually, financially, or even professionally if you have the kinds of skills. But that's it for this one. I've tried to keep it a little shorter, and I hope this is helpful. You can always get in touch with me at admin@bitcoinbuildify.com. If you're curious in some of the other platforms I promote and work with, like Mintage Mining or Crypto World Evolution, don't be shy about asking. I only promote what I've seen results from in a positive way. And with that, don't be shy about commenting or subscribing. I am Trevor. My name is Trevor. I'm the face, the main human behind BitcoinBuildify.com. If you made it this far, thank you for watching, and I hope you watch future videos. So with that, happy cryptoing and have a good day.